All right, guys, back with another one with you here, still on systems. This time we're doing something called elimination. It's our third and final strategy to solve systems, okay? And this one's a weird one. So if we're asked to solve this, again, our goal, just like every system, is to find a solution to this, right? So that would be an x value and a y value. That would be a shared solution for both of these equations, okay? And now elimination, okay? So this is typically used when the equations are like most complex, right? And so you can see neither of these equations are solved for one of my letters, right? It doesn't start with y equals or x equals, right? It has both variables on the same side, okay? And they have coefficients and everything. So these would be difficult to graph, right? We'd have to solve these for the letter y, and they would be difficult to do substitution for. Okay, so elimination is often the third and kind of last resort strategy that we would use. Okay, but it's a pretty cool one. Okay, so look, I'm allowed to do this. Okay, this is mathematically legal. Okay, so I can take these equations, okay, and literally just add them or combine them, okay? Because they're in the same form, okay? So the x term and then the y term and then the constant there on the other side. So I'm able to add these just like I would add, right, two big numbers, right? How you learned it in elementary school maybe. So look, if I add, right, if I do 4x plus 2x, I would get 6x. Now look, this is the key. Negative 3y plus positive 3y. So negative 3y plus 3y. What's going to happen there? Well, those are going to cancel, right? Negative 3y plus 3y is 0y, and those would essentially cancel out, okay? And that's what makes elimination a good strategy to use, is when those two terms cancel each other out, okay? And so there would be nothing there. There's no y term left because they canceled. And then equals 10 plus 2 is 12. And I just have these two, right? 6x equals 12. Now it's super easy, right? I would divide by 6. And so my x value is 2. 12 divided by 6 is 2. Okay? And then I would do the same thing, right? Now that I have my x part of my answer, I still need to find the y answer, right? So I would take that 2 and I would substitute it back into one of my equations. Okay, doesn't matter which one. I'll just do the first one, 4 times 2, right? I'm replacing the x with a 2, okay? Minus 3y equals 10, okay? So I'm going to solve it for y now, right? So 4 times 2 is 8, minus 3y equals 10, and then I would minus the 8 from both sides, so negative 3y equals 2, okay? Now I'll get a decimal here, and that's fine, that happens. Divide by the negative 3. So y equals 2 divided by negative 3, or negative 2/3, okay, or negative 0.067, okay. So I'll just stick with negative 2/3. So that would be it, okay. So that would be, this is an easier one, okay, because it was in very prime position to use elimination. Okay, they're not always this easy, but that's the process. You would just add the equations together, and you should have one of your variables cancel, and you're left with that. And so you get one of your variables, and then you plug back in and you get your other one, okay? So that's elimination. Okay, we're gonna do some harder ones here too, but that's the idea. Okay, let me erase. Okay, so I've got two more systems up here that we're gonna solve by elimination. Okay, so if I look at this number one, okay, again, my goal if I'm solving about elimination, my first step is to add these equations together. And what I want to happen is I want one of my variables, either my x's or my y's, it doesn't matter which one, but I want one of my variables to cancel out. And so for that to happen, for them to totally cancel, I would need them to be the same digit, same number, but just one's positive and one's negative, okay? And right now I don't have that, right? This is positive 2x, positive 4x. Those wouldn't cancel. And this is negative 5y and positive 3y, and that wouldn't cancel either, okay? So in this case, if I'm asked to do elimination here, I have to do something to the equation first, okay? So if I look at these, right, negative 5y, positive 3y, okay, those are both negative and positive, but if I think, okay, right, usually you look at the smaller one and you think, okay, could you multiply 3 by like a whole number to get 5? No, you couldn't. And so it would be really difficult to make that work, okay? Because again, we want to think, okay, what's the least amount of work that I can put in, or least amount of steps that I need to follow to be able to do elimination. But this first one, right, 2x and 4x, right? So this 2, you think, okay, I would ideally, if these would cancel, I would want them to be the same, right? So this negative, or this 2x, you think, okay, for that to cancel with this, could I make it into a negative 4? Yeah, you can. If you multiplied 2 times negative 2, right? Wouldn't 2 times negative 2 be negative 4? And that would work, right? So here's what you would do. You'd take the top equation and you'd multiply everything by negative 2, okay? You can't just multiply one term by negative 2 to change it into what you want. That's not legal. But if you multiply everything by negative 2, then it becomes legal, okay? So basically I'm distributing and I'm multiplying everything on both sides by negative 2. So I'm going to write that right below this here, okay? So 2x times negative 2 would be that negative 4x. Again, that's what I want. Negative 2 times this negative 5y. So negative 2 times negative 5 would be positive 10y, and that's good. And then negative 2 times this positive 10 would be a negative 20. So I had to change this equation up a little bit so that it does cancel when I add the two equations together, okay? So that's the step one that you have to check for, is you have to check for your variables to see if they'll cancel. Okay, but now they will. So I would add 4, and it's always adding here. Okay, you always think add or combine. Okay, so 4x plus negative 4x is 0x, and that cancels. Good. 3y plus 10y gives me 13y. Okay, and just make sure to check your signs too. Okay, these were both positive, so I could just do 3 plus 10, but check your signs. So 13y equals negative 6 plus negative 20 would give me negative 26. Okay? When you want it to end up like this so that you can just very easily solve for one of your variables, right? So I'm going to divide by 13 here, and I get y equals negative 2. Great. Okay? So that's one of your answers, right? You need x and y. So you just found the y answer of negative 2. Okay? And again, how do you check for your x answer? How do you get your other one? Well, you go back in and you plug in into one of your original equations they gave you. You go back and you plug that in. Okay, so I'm just going to take that first one. I know I changed the first one to this, okay, but that's just so I could do elimination. The original equation is still there in red, okay? So I would take that 2x minus 5y, and I would do 2x minus 5 times negative 2 equals 10. And so here, I will get 2x, so negative 5, I think this is negative 5 times negative 2 is positive 10. So 2x plus 10 equals 10, okay? So I'm going to minus 10 from both sides, and it ends up canceling on both, but again, when that happens, I don't feel like slumping down, so I'll write it over here. You would get 2x equals negative, so 10 minus 10 would be 0, and you still do have to write that, okay? So a lot of kids mistake that for it being no solution, because both sides cancel. And that's true if it was variables that canceled, but not with constants. You just write 0 there, okay? And you keep going, so you divide by 2. So x equals 0 divided by 2 is just 0, okay? So the x answer is 0, okay? So when x is 0, y is negative 2, okay? And if you substituted in 0 for x, you should get negative 2 for the y answer for both of those, okay? Okay. Number 2, I made even harder, okay? And this will be the last one that we do. All right. So for this one, 5x plus 7y equals negative 82, and 3x minus 4y equals 0. Okay. Now I'll just tell you on the offset here. We're told in the directions to solve by elimination, so we'll do that. But if it doesn't specify which strategy you should use, if you just graph these two equations in Desmos like I showed in that video, then you'll be able to get the answer that way. Okay. So don't, unless it specifies do this by elimination, don't feel like you have to do that. Okay, but we'll still work it out here. It's just going to be a little bit of a longer problem. So solving this one out, okay, so I look at my two equations, okay, so 5x plus 7y equals negative 82, and then 3x minus 4y equals 0, okay. So again, none of my variables would cancel out right away if I added it right now, how they are, okay. But I look at these, right, and this is a tricky one because, right, So 5x and 3x. Okay, so you think, okay, could I easily make one of these, right? Could I easily make 3x into negative 5x by multiplying? No, not really. And then negative 4y, could I easily make that into 7 by multiplication? No, not really. Okay, so in this case, when you can't just multiply one, okay, you have to multiply both. Okay, and so now we're thinking like least common multiple, which means, okay, I want to multiply. I'm going to need to multiply both of these to get them to eliminate. Okay, but I just think, okay, what's the lowest number that I can make them? And so I'm going to look at the x's here. Okay, so 3x. Okay, basically what the rule is you just multiply. If you multiply by the other number here, right? So this number's 5. Okay, and if I multiply this one, and they're both positive, and I want one of them to be negative, right? So if I'm going to multiply the bottom equation by negative 5. Okay, multiply everything by negative 5. And so let's just do that and let's see what we get. Okay, I'll show you why I picked that. So negative 5 times 3x would be negative 15x. Okay, negative 5 times negative 4y would be positive 20y. And then negative 5 times 0 is still 0. Okay, so I chose to multiply by negative 5 there because, okay, if I left the top equation the same, it's still not going to cancel. But what can I do, right? What can I do to make this x term cancel with this one, right? All I need to do is turn this 5 into a positive 15, and it'll work, okay? So with that one, I would multiply the top one by 3, right? I multiply everything here by 3 to make that work, okay? So if I distribute a positive 3 to this top equation, okay, 5x times this 3 would be 15x, right? And that's what I want. Now these two will cancel, okay? So basically the rule there is multiply by that other number, right? So I multiply the top equation by the 3, multiply the bottom equation by negative 5, and so that made them able to cancel, okay? I could have done it with the y's as well. I could have multiplied the top one by 4 and the bottom one by 7. Either way you would have gotten variables to cancel. Keep going though. 3 times 7y would be 21y. And then 82, negative 82 times 3 gives me negative 246. Big number there. I add these now, right? Now that I can have one of my variables cancel, okay? 15x plus negative 15x cancels, right? So these x's cancel, and I'm good, okay? 21y plus 20y gives me 41y, okay? And then negative 246 plus 0, it's an easy one. Still negative 246. All right, now if I continue to solve this, I would divide, right? I divide both sides by this negative 41. Again, you can use a calculator with these bigger numbers, but you would end up getting y equals negative 6. Okay, y equals negative 6. And so that's the y value. And again, you are not done. You are so close to being done, but you're not quite done yet. You just found your y answer, right? You need your x answer too, okay? But you did the hard part. You found the first answer, so now you go back and you plug that in. I'm going to plug it into this bottom one here, okay? Either one of the original equations is fine. And technically, you could plug it into any one of these new ones as well, and it would give you the same thing. But I'll go with one of my originals. Okay. So this bottom one, 3x minus 4, not y anymore. It'd be negative 6 equals 0. Okay. So I'll do 3x, and then it would be negative 4 times negative 6 would be positive 24. So 3x plus 24 equals 0. Okay. I minus a 24 from both sides, okay? So 3x equals negative 24. I divide by 3, so x equals negative 8. Very good. X equals negative 8. All right, so that's my x value, and I found my y value first. Okay, so there is solving by elimination. Hope that makes sense. It's a little tricky at times with some of this stuff, but I hope that makes sense. Thanks for following.